Good morning, all you wonderful people. I hope you're feeling great today. I'm kind of feeling a bit struggling, so we'll see how we go. Also, I don't know how well this streaming setup is going to work. I've thrown it to a totally different computer. I'll get back to that in just a second, because hopefully it will allow us to do some cool things. But first, I acknowledge the traditional owners of this land. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, for quite a while now, one of the things that has frustrated me is that I've been unable to capture the screen of my computer if I'm streaming, like if I'm running OBS. I can't run, well, I can for some things, but I can't for Fusion 360 and Eagle, I think I can, but I really wanted a way to be able to have a reliable desktop computer that wasn't bogged down by doing the streaming and still have the stream. Oh, it looks like I'm getting skipped frames, so this is not a good start. So what I've done is set up my old iMac on the side, and that is now doing HDMI capture off a screen on my main computer, which means the main computer is not slowed down by doing the streaming. Anyway, the point of all of that, yeah, I am getting skip frames. That's not a good sign. But the point of all of that is I want to be able to do things like, is it going to switch? Ooh, it's really struggling. Like that. I want to be able to run Fusion 360 and do some design work in that on live streams, which would be really, really cool. And also do some stuff in Eagle. Mess around live in Eagle and get feedback while I'm working on things. In fact, that's one of the things I want to cover today. But first, tell me how you're all doing. Moo Sion. We've got Austin, Jordan, Stefan, Stephen, Turbotronic, Scott, Michael, Gerald, hey. And others, 50 Hertz, Dodgy, Akim, thank you for coming along. Hey Chip, no, you're not really late. You're not late at all. I've only just got started and said hello, and that's pretty much it. So, I came into this today once again, without a topic. I just noticed also without Steve. Now, hang on, I'm going to switch back. Can I do that? Yes. Steve is, where is Steve? He was just here. It feels wrong to be doing a live stream without Steve now. That's right. I was moving all sorts of things around, so Steve can come back on to here. This adhesive, I think, is not going to stick because it's been on and then removed again. So Steve may take a tumble. We'll see. We'll see if he hangs around for a little while. Oh, Johnny just said still recovering from COVID. Have slept for 2 days. Oh, I hope that you do recover quickly. Oh yeah, that's tough. Jordan said down with COVID, so home for another 5 days. Wow. Yeah. Chip just had to get my booster. Scott says, isn't it about time you install a permanent Steve mount? Yes, it most definitely is. What I need to do is actually attach something to the chair, like screw it in properly. Yeah, it is time for that. One of the reasons that I haven't really done that is I've been thinking about how to animate Steve, because I want to do something like ideally have a servo or something inside it, so his little paws can move. I want him to be able to open his arms up. Yeah, Stephen says the conveyor controller seems like a good place to start. Yeah, I've got some questions about that. I've got some ideas. But yeah, I'm sad to hear that several of you have COVID, like right now, or are recovering from it. Jordan asked a very good question, which is why not use the ATEM? And I've been trying to figure out ways to do that, like ways that would work with the flow of what I want to do. Now, for simple situations, for most things, the ATEM would be fantastic. Ideally, what I would want is something like the ATEM Extreme, which is the one with 8 inputs. The one I've got is the regular size one, which has got 4 inputs, and it's not enough. Because what I would need to do is capture my front camera is 1, overhead camera is 2, microscope camera is 3, desktop is 4, then things start to get complicated because I also want to bring in the web interface for the on-screen display for the multimeter, and then there is another camera on the oscilloscope, so that would be a 5th. Actually, that one's USB, so that's USB camera, which the ATEM can't do. I've got another face camera here which goes down the bench, which I use when I'm using the overhead camera. That's USB. The ATEM can't connect to that. And yeah, there are a couple of other things. Oh, the other big problem, the really big problem, is that it only has a single, I can't remember the term for it, but basically when you're doing picture-in-picture, like when I'm doing this, come on, change. When I'm doing this, on the ATEM, I could do this okay. I'd be capturing the desktop and I'd be capturing the front camera and then doing an overlay, but you can't do 2 overlays. It only has a single channel, which means that I could not do this plus capture something like on-screen display for the oscilloscope or other things. Basically, it is yeah, it's too limiting. I really need the flexibility of OBS, which allows me to overlay lots and lots of different things. So, okay. Steve quick release system. What I could do is put Steve on a camera mount. What I did a couple of years ago was ordered a heap of those little quick release mechanisms on AliExpress, and I converted everything to it because I had a few different tripods, different cameras. And so what I did was I put one, do I have one here? Not handy. I put one on everything. So every camera I have, every tripod I have has an identical quick release mount system on it. And what I could do is put a camera quick release mount on the chair and put it on the base of Steve so he could just snap into place. Yeah, so Peter says the ATEM is a switcher, not a mixer. That's right. It is. No, I did not mean to wake up my voice assistant. Yeah, basically it is good as a way to bring in multiple HDMI sources and switch between them. It's not so good if you want to mix those sources and do complex layouts and overlays and all of that sort of thing. It doesn't really do that so well. So if you want to do 4-channel HDMI capture and be able to switch between those sources and possibly overlay one onto another, then the ATEM is fantastic for that. But it is definitely no substitute for OBS. All right, what? Oh, something just weird just happened with my screen. I think it's because of the screen capture. Okay, now, welcome to another episode of Over-Engineering a Squirrel. Yes, Michael, that's right. So, that's right. I was just in the process of saying, yeah, sorry to hear about all the people who have COVID right now. I just heard, so yesterday, my niece tested positive for COVID, which means that my sister and the rest of her family are pretty sure to either have it already and not yet be showing symptoms, or given that they all live in the same house, they will all have it. It's almost impossible to isolate within the same house, so it's pretty much inevitable that my sister and her whole family will have COVID very, very soon. Okay, there is a problem going on with my screen capture. So that is something I'm going to have to fix. Right. Yeah, oh, Joel says, I use OBS with a couple of Blackmagic HDMI cards at work. It's a separate machine that runs the stream, lets me combine 4 HDMI streams to one. Yeah, cool. That sort of thing would be nice, but the Blackmagic hardware is expensive. Really, really good gear, but expensive. I wish I could use that. Yeah, I've got... So at the moment here I have the ATEM Mini Pro. I've got an Elgato Cam Link, which is what is working right now to capture the front camera. I've got an Elgato HD60S, and I've got 2 other little Chinese FPGA-based HDMI capture devices, which is what captures the overhead camera and the microscope. Why do I spend so much time on these streams talking about the streams instead of talking about interesting things? It just seems to be the way. Right. Let's get on to something interesting. Okay. I have a question for the Brains Trust. I'm going to call on your expertise. But first, some backstory. In order to use the new KO pick and place machines, I need a conveyor belt to link them together. So I've been working on a design for a conveyor belt. And Jordan, yeah, so these are interesting to some of us. I'm sure, yeah, talking about streaming is interesting. It is something that's interesting to me as well. And the whole thing of messing around with this setup and trying to arrange things in a useful way and getting the control system. So I'm also running Touch Portal on an Android tablet, which is linked over Wi-Fi to the Touch Portal program running on my iMac, which then connects, does a socket connection into OBS, so I can control camera selection and things from the Android tablet. That's actually what I use to do these changes, like when I click on desktop versus front camera and that sort of thing. I'm doing that on a tablet, which is sitting in front of me. And yeah, doing all of this stuff is really, really interesting. It's just that this is not really meant to be a live stream about streaming issues and problems and things. So yeah. Yes. Oh, XSS Adventure says there's those cheap HDMI to UTP converters which actually just do Ethernet plus motion JPEG. You could feed that into OBS. Yeah, that'd be cool too. Lots of things I can experiment with. That is actually a really good point, because one thing that I would like to do is have cameras that are a bit more remote. And for example, the overhead camera, that's got a fairly long HDMI cable on it that goes to the HDMI capture device, which then has a really long USB cable on it, I think a 5-meter USB cable that comes down and around and under the bench, etc., and plugs into the computer. And so I'm really pushing the limits of the distance from the camera to the computer. I'd like to be able to do things like put a camera on the far side of the room, like just a general room camera, but that would mean, I don't know, 15 meters of HDMI and USB cable. Maybe have cameras elsewhere and be able to feed them into OBS as well. I'd like to be able to put cameras inside machines, like put cameras inside the pick and place machine and all those sorts of things. Put a camera inside the laser cutter. Put a camera on the CNC machine. But to do that, I can't really just use that HDMI to USB sort of chain. I need some way of capturing the video or injecting the video over the network and then pulling it into OBS, like as a using NDI or something. Anyway. Oh no. Sion, while you're all enjoying talking streaming, I'm in my garage in 57-degree heat with a 300-degree oven running running some boards. Hope the dripping sweat doesn't hit a board. Oh, Sion. Sunday morning working in the sweatshop. Andrew Gordon says ESP32 cams. Yeah, I've got a whole box of those. they're okay, but the video resolution is crap, and there's quite a lot of latency as well. It is nothing like the quality of a proper digital camera running HDMI out into a capture device. Yeah, they're not worthy of live streaming, exactly. I was actually thinking of putting one of those. This is another thing I wanted to do. I've been wanting to put a camera on my robot mower, like mounted maybe up on the back somewhere, but looking ahead, and be able to stream that. And of course I could do something like get a wireless security camera and, you know, glue it or screw it onto the top of the mower. But one option for that is something like an ESP32 cam. What I can do is pick up power from the mower, because it's got a moderate sized battery pack in it. It's got to run the motors and all of that sort of thing. So it's got pretty decent batteries. And it's got a USB port on the bottom, which is used for firmware updates and, you know, all of those sorts of factory reconfiguration things. So what I can do is make a cable that plugs into the USB port on the bottom of the mower. I'd have to make sure it's all environmentally sealed, and then just tapped 5 volts off that. So I could use that to power something like an ESP32 cam and stick that up on the top. Yeah, Pi HD camera, that's another option. That takes, they take a fair bit of power just because of the Pi. Lots and lots of fun things. So back to the story. Story time, folks. So I've been working for a little while on these, on the design for this conveyor, and because I've just been messing around with this system, I actually do not have my overhead camera or the microscope camera working today, so I can't do that. But I can hold things up in front here and show you what I've been doing. So just over here, this is in a kind of partially complete state. Now, where do I get this so you can see it? Right about there. So fixed front rail. You can see there's a square frame at the bottom. There's a fixed front rail. There is a back rail which is on linear rails, so it can move backwards and forwards. There's a timing belt here, GT2 belt that goes through. There's a stepper motor at the front, and there's a homing switch at the back. So if I take that cover off, there's a little optical homing switch. So what it can do is drive the, and you can see there's a tiny little drag chain there. Really cute. I love this drag chain. I think it's a 5mm drag chain. So what it can do is run the rail to the back, home itself, and then this bit of painter's tape that's on here, I just stuck that on because I was drawing marks with a pen for calibration purposes. So I've got it calibrated so that I can home it, and then tell it to go to a certain width, like go to 220mm, and it will move down to suit a 220mm PCB. And then the conveyor can move the PCB along. Just by touching the edges, it doesn't touch the bottom of it. And hanging off the front here, this is where, so yeah, this hardware is, the mechanicals are all pretty good. That seems to be working fairly nicely now. I do want to make a couple more changes just based on what I've done so far, but that's all right. Now, the controller, the thing hanging down there, that is the interesting bit. And what you can see is there is a big screen. That's an ESP32 with a touchscreen. There's a power source, and there is the driver for the stepper motor. I'm going to put all this down now because it's quite awkward, because I can show you, now you've seen the overall structure, what's going together, we can look at individual bits and pieces. Okay. So, where was I? That's right. So, the controller. This is something that has actually been around for a little while. I hadn't bought one before, but when I was looking for controllers for this project, I saw these and I thought, that is perfect for this, and could be really, really good for home automation projects. So unfortunately the overhead camera is not working, I can't do that. But basically it's a touch screen, it's a capacitive touch screen, so it's not resistive. It means that it's really sensitive. It's actually multi-touch, supports I think 2 touch points. And on the back of it, there is an ESP32 module and a couple of breakout, it's backwards for me, a couple of breakout headers here. Now these headers are actually identical, they're just wired in parallel. It's the same connections on here as on here, but the idea is that you can make an add-on board that plugs into this, and you can use whichever of these headers suits you better. So you can use like a vertical format or a horizontal format. Austin says, I have one of those screens. They are great. Yeah, so for those of you who are playing along at home, it is the WT32-SC01. And it's got USB-C on it, so there's no power management, like there's no battery system or anything like that. But because of the size of it, this would actually be perfect to make a touchscreen panel for a home automation system. It's like light switch size, or just a little bit smaller than light switch. Yeah, so Austin said, I've been wanting to make a shield that has Ethernet and PoE. I actually laid one out. I'm going to get to that. And then I took the Ethernet off it. But yes, what I would like to do is make an add-on board for this that has Ethernet and PoE on it, because then what you could do is mount this inside a wall panel, run Ethernet to it, and now you've got an Ethernet connected touchscreen for remarkably little money. I can't remember the numbers, but it's something like 30 bucks for this. And considering the quality of the screen and the fact that it's capacitive touch, all of that sort of thing, it is really, really good value. So I bought 2 of these just in case I screwed one up. I wanted one that I could put on the device and one that I could use for testing. And yeah, I think I probably should have bought about 10, because these things are really, really cool. Yeah, the way the screen capture is working, this is not going to be feasible long term, because it keeps rejigging the monitors. You can't see what's going on because I don't have screen. I'm not streaming the screen capture right now, but the monitor on my main computer keeps turning off and back on again, and then it rearranges all the windows, which is no good at all. So now there's one thing that is on here that I have not yet figured out. I've looked at it and not really dug into it. Maybe Austin knows. Yeah, so Austin says $40 Canadian for the display. Yeah, that's right. I think it's like 30 something bucks US. I can't remember how much I paid for it, but it was, you know, somewhere in that region. So, excuse me, very good value. Now, one thing that I was a little bit unsure about is that at the top here, in the black surround, there is an opening as if there's meant to be a camera or something there. And I can see on the PCB behind that there is a footprint for something, but there's nothing there. So I've been wondering whether this was actually designed to have a front camera, and then they just never populated it in the design. Don't know. But anyway, really, really interesting little board. So now one thing is that it is kind of limited in terms of the I/O that they make available on these headers, and I think that is because a fair bit of the I/O is actually used up already internally. So it's got an I2C interface to the touch screen, the touch controller for detecting the points that come back, and it's got SPI to the actual display controller. Yeah, but the design is, it seems really, really decent. For example, there are 2 voltage regulators on here, and they're running dual power rails, because what they do is have a separate power rail running the LCD, I think. Is it the LCD? Something like that. But anyway, the idea is that they have actually doubled up the voltage regulators so they can run a separate power rail for the processor versus the other parts of the board, so that it has really good stability. And yeah, so it's well thought out. Basically, it's been designed it hasn't been designed down to a price. It's been designed properly, like decent quality, and it just happens to be cheap, which is a really big bonus. So this is the screen that I currently have running, not just the screen, but the processor that I currently have running that conveyor belt. So what I've been working on is an add-on board that goes onto the back of this that is going to provide a whole lot of connectivity. And that is what I will show you now. Ah, right. Andy says, what was the model number again? Link, please. Okay, let me find that for you. I guess what I can do is put in a an Amazon, not an Amazon, an AliExpress affiliate link, although that's not necessarily the best thing. I think Seed is probably the best place to get them. I'm just going to look it up on Seed. Here we go. This is, yeah, you can buy it from a few places. I ended up ordering it from AliExpress. Yeah, Austin, oh, you're not a mod, you should be a mod. All right, so this is the link to it on Seed. And, hang on, how do I make you a mod? Let's see that. Austin, add moderator. Boom, there you are. Okay, so, yeah, I bought mine from AliExpress. So it's $39.90 from Seed. I'm looking up my spreadsheet right now, my parts purchases spreadsheet, to see who I got it from. Where is it? So this is this screen is something that I can see myself using a lot in the future. It could become like my go-to little screen sort of thing. All right, I will drop in. It's an affiliate link. Sorry about that. But that is to the AliExpress seller. So this is where I actually bought it, 29 bucks US. And was there shipping? Yeah, there was $8 shipping on that. So that's not necessarily the best place to buy them, but that gives you a couple of options. So you got Seed and the random AliExpress seller that I ended up buying mine from. If there are better suppliers, let me know. Cool. Austin said there are 4 megabyte and 8 megabyte and 16 megabyte versions of the screens. 4 and 16 are the more common ones. Yeah. Ooh. Peter only wonders why John has never given me moderator rights. It's because I don't trust you. So, no, not at all. It's just never come up. Yes, actually, Johnny, you're right. I need to take Peter's privileges back away from him. he would do something to kill the stream at lunchtime. Okay, so where was I? That's right, I was talking about these boards. I'm just going to close that spreadsheet. Let's, why am I not showing you all of this? Okay, come on, desktop, switch, there we go. Okay, so this is the page on Seed for that particular board. And this is it from Creation Store on AliExpress, which is where I got mine. What's their feedback? 97.6. That's kind of okay. It's not great, but it's not red flag territory yet. So yeah. Anyway, I bought mine from there, and they arrived quickly. Hang on, how fast did they arrive? Let's I'm just Google Drive parts orders. Hopefully I didn't just reveal something that I shouldn't have. All right, so this is my parts order spreadsheet. One of the things I track is how long everything takes. Where was it? WTS, there it is, this one. It took 15 days. So I ordered it 27th of December, right between Christmas and New Year. It arrived on 11th of January. So 15 days from China to Australia, and I didn't pay for extra, shipping speed or anything. That was just regular shipping. Tradie Trev, stop making me spend money. Yeah. Oh, Austin said the missing part is the U1. It's an IR proximity sensor, VCN L3020. That is cool. So yeah, not a camera. I think a camera would actually not be that useful in this situation, but a proximity sensor, that is really useful. So you could have the screen asleep, and as your hand moves up to it, it wakes up. Very, very cool. If we can retrofit that proximity sensor, that would be nice. I wonder if I've got any of those. I did get some IR proximity sensors a little while ago. I've got a project. In fact, one of the other things that I'm going to talk about today is little time of flight sensors. VCNL 3020, I think I have these. Maybe. Yeah, the Vishay sensors. So, the issue is going to be getting in there to fit it, because that screen, how is it attached? Is it glued? I don't want to be breaking glue and those sorts of things. It looks like it is. It looks like there's double-sided tape in between. So what it would mean is cutting the tape, folding back to here. So cutting the tape, the screen, if I get the angle just right, no, you can't quite see through it. There are two pieces of tape that I can see, double-sided tape. So what I would have to do is get a blade in there and slice that tape off, fold the screen open to get access to the pads that are on this end, and then I could fit the time of flight sensor on there, maybe put new double-sided tape on and fold it closed again. It's a pity they didn't include that. It's probably just like one of those unobtainium things. I can feel a sneeze coming on. That's not good. I'm not sure if I hit mute in time. Okay. Now it's back. Okay. There is a huge lag between me sending commands into OBS and it actually responding. It's like 5 seconds or something. Thanks, Dodgy. What diabolical plot. Yep. So Trev said, that's about the size of a normal light switch and outlet. It is. That's right. Here in Australia, at least. In other less civilized parts of the world, they use different, odd, really weird shaped light switches, like square plates. Looks ridiculous. Looks like, I don't know, like something from a kid's, like a kid's toy. Here in Australia, and in China and in many other, and in other places around the world, this is basically the aspect ratio of our light switches. And so this would fit into a blank panel really, really nicely and would make a wall-mounted touch screen. Austin says it works natively with this. Hang on, back to desktop. OpenHasp. Okay, so we can load that onto it. Yeah, so that plus a board on the back to provide power to it, that would be really, really nice. Oh, yeah, this is designed for a Wemos D1 Mini and a Nextium display. So this is just it's a Rover module, which is equivalent to the D1 Mini kind of, and the Nextium display. So fantastic. Okay, thanks for pointing that one to me, Austin. Do I know what chipset the LCD on the WT32SE01 uses? Is a question from Patrick. It is, let's see, so that one, where are the specs on this? Come on, display. I don't think that has got the details on it. Are they in here? I do have the datasheet for this module somewhere. Display, it just says capacitive touch with 2-point multi-touch. Come on, where's the driver information? Now, one of the things is that they are, oh, maybe it's in the comments here. I think someone was posting it. Here we go. The video driver is the ST7796S, and the touch driver is FT6X36. So, yeah, I've got it working. Like if I power that one up, I've got maybe I should just do it. I'll do it with a battery, just to be simple. Will I, won't I? Or power cable. I'm going through the decision tree right now. No, I will use... Where did the battery go? I had a battery that I was using with this. Just like a big LiPo. Oh, it might be out in the other room. Hang on. Let's see if there's any charge in this gel cell. I don't know if there is. This may be dead. It's going to be kind of awkward holding this, but let's give it a go. Now, I'll just power this up. Okay, so this is not, I don't know if you're going to be able to see this at all, but yeah, that display has now woken up and it said that it is the Superhouse conveyor controller. It's connected to Wi-Fi. It's telling us its IP address. It has subscribed to MQTT. So I can actually send G-code commands as MQTT messages, and this responds. And it's also reading the touchscreen, but it's not doing anything at the moment. It's just, if I connected the serial console to it, it would be reporting the XY coordinates of touches in the serial console. Yes, it has an ESP32 on it. So home ace. Interesting. The question is this better than a next-gen display? So, as far as I understand it, I may be wrong here, but this is just my understanding. The next-gen displays are generally designed to act as a secondary device and provide the user interface within the display, and then you put your own microcontroller on as a separate device. So it's like the display is a standalone module running its own code with like a drag and drop sort of GUI builder system for it. So what you can do with the next-gen displays is design your user interface in their software, load it onto the display, and then your own microcontroller can interoperate with it. I think that's generally how they're used. Now, this particular one has an ESP32. It's got the display, but it doesn't have like the embedded controller in the display. So in this case, what I was just showing you, hang on, was I running on, when I was waving that around, did I still have my desktop? You probably couldn't even see it. So yeah, so with this, what I'm doing is the code that is driving the display is directly in the ESP32. It's not separate in the display itself. And I think that might be why this whole thing is cheaper. Because next-gen displays, I think, are moderately expensive. It's like a complete self-contained system, including the microcontroller, that does all of the HMI stuff, but then you have to add your own thing onto it. Anyway, so where I was getting to with all of this, this is a really cool little board. And as I said earlier, I can see myself using this board for many other projects in the future, and it just got me thinking about things that I could build with it. So let's have a, in fact, what I did was, if I come back to here, where is it? Oh yeah, so I started off by doing a template, and it doesn't actually, you can see that I copied it from something else. It doesn't actually have any of the connections on it. All I wanted to do was get the Open Managed Libraries to update. Okay, let's do that. What I wanted to do was, no, I've already updated this. I don't know what it's talking about. So what I wanted to do was basically just capture the dimensions of an add-on board for this module as a starting point, so that then when I want to make things for it, I don't have to start from scratch. I've got a template that I can use. Okay, it's done. And so what I did was I got all the dimensions, put the mounting holes in there, and put in both orientation connectors. So it's got the horizontal and the vertical orientation connectors, and they are in the correct place. So the idea is that when I want to start making a project that is based on this module, I can just duplicate these files, delete whichever connector I don't want to use, and away I go. And then in the schematic, it's got all of the signals here. So I don't have to spend ages messing around with the data sheet and trying to figure out which pin is which. It's all right here, it's all labeled. And did I do the J's on it? Oh yeah, so I've got purposes. Some of this was because I was starting to mess around. I need to clean up this template, but anyway. It's not 100%, but it's a starting point. So then what I did was in here, oh yeah, I'll get back to, so this and this I might get back to later. We will see how we go. So this is what I've been messing around with. No, I do not want to. Okay, open managed libraries to update. I bet there are no libraries to update. I'll let it do its fetch, and then it'll say, nothing to update. So stop complaining, Eagle. Come on. Fetching, fetching. Done. See? Nothing to update. So stop complaining. Nothing to update. All right. So what I've done is, this is the add-on board specifically for the sorry, got to get my brain on track, for the conveyor belt. The reason that my brain went slightly off track was I saw a comment by Austin saying, I have an updated size accurate footprint and 3D model for the PoE module, the one used on the Rack 32. Awesome. Okay. That would be really handy. Thanks for letting me know, Austin. So anyway, back to this. The point of this is the board. What I'm going to do is make a 3D printed enclosure that will go on the front of the conveyor system that will hold the touchscreen at about a 45-degree angle. You know, something. Basically, the idea is I want to be able to walk up to the conveyor, have a keypad on it, and type in 54, go, and then have the conveyor belt width adjust to suit a 54mm PCB. So I want a touchscreen interface on it. And all right, let's do a quick rundown of all the things that this needs to do. I have the touchscreen for the status display and for user input. It needs to be able to drive a stepper motor for the Y-axis to move the position of the conveyor. It needs to be able to drive a pair of steppers for the X-axis, which is what turns the conveyor. And my first version, the version I've just shown you, actually has DC motors. But there is a good reason to change to steppers. Will I go into that now? Yeah, why not? So my plan originally was to make this conveyor belt system as cheap as possible. So my first design, and what I just showed you, uses little N20 gear motors. And I'm using 5 volt, 100 RPM N20 gear motors. And they're okay, they're strong enough, they do the job. I can control their speed by PWMing it, and that's working off that system right now. That's okay. But one of the things I want to be able to do is have a PCB come onto the conveyor belt and then move it to a known position. And with a DC motor without some kind of a feedback loop, you can't really do that, because I could be PWMing the motor and have the conveyor moving at a certain speed, but you're still only guesstimating where it is at any point in time. So if you have a sensor that detects the PCB has come onto the conveyor belt and you want to move it to the 27 centimeter position, all you got to go on is time. You can just run the motor for a while and then you can stop it and hope that you got it at that position, but it's not going to be very accurate. So so what I want to do is switch to stepper motors for the for driving the conveyor, the actual conveyor belts. And that means that I will have more accurate speed control. I'll be able to calibrate it and say, I want it moving at 400 millimeters per minute, or that sort of thing. I can match it to whatever the devices are that it's joining. And it also means that I'll be able to have a board come on and then move it to a precise position and then stop it, because I know how many steps it takes to move to that position. So anyway, that was the kind of background story. So we need a stepper controller for the y-axis, and we need a stepper controller for the x-axis. Okay, then we need board sensors, and this is where the time of flight sensors come in. Where do I have one? Here we go. Here is a little time of flight sensor. Hang on. I am bashing into things and messing things up. So this is, which one is this? This is a VL53 time of flight sensor, which is, it's another one of those. What are you doing, Steve? I just heard a strange sound. Yeah, it's I heard the adhesive letting go. Steve is trying to dive off the back of my chair. So this is a time of flight sensor. It'll measure down to like millimeter accuracy between, I think it is 50 centimeters and 6 meters. Like it's really quite amazing. It's basically like a single dimensional LiDAR system. It's a laser reflectometry system. So, and at the moment I've got that wired to a Lowland 32 just because I was testing it. So this is what will be used as the board detector, mounted just beside the fixed front conveyor belt. So I'm going to have two of these, one at the left end of the conveyor, one at the right end of the conveyor, so that as a board moves onto it, it'll basically be pointing straight up, and it will detect that a board has entered, and then we'll know where the front edge of it is, and then it can stop it wherever it needs to along the length of the conveyor. Okay, so we need two time of flight interfaces. There is a complication with these time of flight interfaces. I'm going to get back to that because it's actually kind of interesting. Then, hang on, I'm just going to do some moderation there. Okay. Then what else do we need? Okay, we need voltage regulation because this is going to be powered somehow. I'm not going to say much more about that right now, but yes, PoE. Then what else do we need? I'm just looking at this design. We also need ready in and ready out connectors. Now, this is something that has been taking, it's been taking a bit of digging because it seems surprisingly that there is very, very little standardization on this in terms of how it works. And I've spoken to a couple of people who work on production lines, like build equipment for production lines. In fact, my cousin's husband has a company that builds production lines, and Lachlan, whose factory that I'm going to be moving into before long, builds stuff that goes on production lines. And so anyway, the point of all of this, the point of ready in, ready out connectors, or signals, imagine you have two devices on a production line. For simplicity's sake, let's just say we've got two conveyor belts and they are end to end. So you can have an object moving along the conveyor belt. It moves off one conveyor belt and onto the next one. Now, if you have something like, say you're moving boxes around, this might be like a shipping facility or something, you're doing some sorting. You have a box that is on your second conveyor belt, and it has something being done to it, like maybe bottles are being filled or stuff put into a box. You don't want to move that conveyor belt. It needs to be stationary because there is some action or there is something on that conveyor belt. That means that the conveyor belt that is feeding into it can't just send stuff to it. It has to stop and wait until the destination is ready. And so devices that are on production lines have what's called a ready in and a ready out signal. and they are a way of indicating between each other, yes, I am ready to receive something from you, or hey, I have something for you, I would like to give it to you. So that's the general principle, and it's generally done using like a dry contact system. So they'll have a relay, because all of this stuff is generally like industrial scale. We're talking about production lines in factories. They often use 24 volt for signaling, so there'll be something like a relay, and when one of the devices wants to tell its neighbor that it is ready, it'll fire the relay and close the contacts, or the other way around, whichever way. It might be like normally closed so that it's a fail-safe system. So if the device is turned off, the contacts will open, and then the upstream device will not be able to send anything to it. Anyway, all those details. So the point is, there needs to be some way of these devices communicating with each other to be able to coordinate moving objects from one to the next. So we need ready in and ready out signals. And I thought that there are so many production lines in the world. I thought that this would be a 100% standardized, solved problem. There would be standardized connectors, standardized signals, all of that sort of thing. Turns out it's not. And that's kind of rubbish. So one of the jobs that people have to do when they're building production lines is this whole thing of integration of, I've got this machine and it needs to talk to this machine, how am I going to wire them together? And they provide input and output signals, and you've got to kind of match them together. So what I was expecting to find was a specification that says ready in and ready out signals for machines on a production line should use this connector, and they use this cable to link them. This is the pinout. These are the signals and how they are, how they're dealt with. Maybe there is something like that, but I can't find it. It seems that everybody just kind of makes it up as they go. Very frustrating. So what and also in passing, the KO pick and place machines that I'm going to be linking all of these to do have ready in and ready out signals. They've got, there is a cable that comes out of them that you connect into the next device. And often with these sorts of things, because they are wired in place, it's not really, like once you're setting up a production line, the cabling is often semi-permanent. So there'll be things like screw terminals on a PLC in one of the devices, and then you attach cables to it and terminate it and screw it all in, and then you route the cable through the framework or attach to the framework and take it to the PLC of the device adjacent to it, and then you screw it onto the terminals. So a lot of it is bespoke, and it is kind of semi-permanent. It's wired there for the life of the production line. It's not going to change. So, Sion says 4-pin DIN. Sometimes you need to flip the positive and negative signal, but check out the generic conveyors from ETA, Newton, etc. Yeah. Trady Trev says, why not use Modbus? Only a couple of wires and old school and open source. That's the way many PLCs talk to each other. Yes, there are many, many ways that this could be done that would be better than the chaos that it is at the moment. Yeah, so, so Sion says it is solved. 4-pin DIN, okay. Celtic Beast says, is John going to propose a new standard? No, I am not. Right, so I asked KO about this. Now, one thing about KO is their customer service is amazing. I have sent them questions. I've never bought anything from KO, and they know that. I've told them that I have bought machine. I now own 3 KO pick and place machines that I bought secondhand. So I didn't buy them from them. They haven't got a cent from me. And yet I send questions to their support and I get immediate answers. So I sent an email to them asking about their ready in and ready out connections. And I think about an hour later, I got back an email with a PDF with photos of the cable locations and the colors. And it said, if you are connecting to an inspection conveyor, then wire these colors on the KO machine to this on the inspection conveyor, and those sorts of things. So anyway, I got no complaints about KO tech support, but it's just this whole thing about it being a little bit make it up as you go and lack of standardization that is annoying. So anyway, ready in and ready out, and Sion says that it's a solved problem with 4-pin DIN connectors, and that would be friggin' awesome. So I am going to look at what has been done on ETA and Neodyne, etc. So I will check that out. Now back to, where am I? Desktop, which is what I was wanting to show in the first place. So on this, we need ready in and ready out connections. Oh, and also it needs a limit switch to home the Y-axis. So the result is, this is where I've got to so far. Can I make that smaller? No. All right. I've got the mainboard header that goes to the touchscreen module, and I've got an MCP 23017 because I need more GPIOs, and I've got those connected to different things. So I've got 2 stepper motor modules, which you will see, and the idea here is to use external modules instead of building the stepper drivers directly onto this board, because I want flexibility for a different use case, which I will get to in just a moment. But what I've done is put down the footprints for 2 of these stepper motor drivers. So you can go old school and put something like an Allegro A4988 or whatever it is. Is that the part number? Whatever. Yeah, one of those little modules on there. These are the modules that are typically used in things like 3D printer controllers. There's the Y-axis limit sensor, and at the moment I'm using an optical sensor, but it can also work with a mechanical limit sensor. And second sheet, what have we got? CAN bus interface. Okay, let's get back to that. Then we've got PCB sensors. So I've got 2 headers on here, and these are IDC headers. They're 6-way headers with 1 pin not used. That was, I kind of went around and around on the connector choice there. I will get back to that and explain that in a moment. There's a voltage regulator. At the moment I've just slapped down a 5-volt 3-amp regulator module. There's a power switch. Power switches. Power switches are a remarkably hard problem, particularly if you want more than like 100 milliamps. Do you know how low the power ratings are on the switches that people commonly use? It's really surprising. Like, if you get like a little slide switch or something to mount on the edge of the PCB, they often have current limits. Like the really small ones, the surface mount ones, they typically have current limits that are like 50 milliamps. And if you get one of the bigger ones, like a larger slide switches, the ones that are maybe, 7 or 8 millimeters tall, etc., their current limits might be 500 milliamps. If you're really, really lucky, they'll go up to an amp. They are surprisingly low power rated, and most people tend to abuse power switches. Abuse switches, I think, because they don't really take into account that the ratings on the contacts are really surprisingly low. So anyway, you are on the design, you're going to see a huge power switch, and that's the reason. So I've got a double pole, double throw switch, and then I just doubled up the gangs. Then we've got ready in and out left and right side connectors. What else is there? CAN bus we'll get back to in a moment. So, okay. So, what I've got here is an opto-isolated input and a read relay output. And the idea is that if your adjacent machine wants to know when we are ready, it can provide its own signal. So this is typical. So this is basically the classic dry contact output. The PLC or whatever it is that's in the next machine can simply put, say, a power. It might put 24 volts onto this, and then it'll take an input with a pull down on the other side or something, whatever it does. So with this, what we can do is just switch this relay using this transistor to control this dry contact output. So that's how we can send our status to the next machine. On the input side, 5 volt, yeah, okay, that'll do. I was just thinking about design choices here. Okay, so I've got an opto coupler here, and this is the opposite side. So if you imagine that the machine at the other side has some kind of a dry contact output, and we are wanting to read from it, what we do is provide 5 volts through a current limiting resistor, and then it goes out this connector and then through their relay, and then comes back in again and drives this opto coupler. And that's because this cable might go for, could go for a few meters in an electrically noisy environment. So this isolates our input from the dirty outside electrical environment. So when the external relay contact is closed, power runs through it, this LED turns on, this transistor turns on, and it pulls this input low. When it's off, it goes high. So that's a logical low to detect a close on the output, on the other machine's output. And it's got the pull-up resistor to pull it high when the transistor is not turned on. All very straightforward. So what this gives us is a ready in connector, like a ready in signal and a ready out signal. And then we've got two of them. So I wanted to put one on each side so that if you're daisy chaining a few machines together, we might be reading from the ready out signal on the machine that's upstream. We might be giving our ready out signal on the other side to a machine that's downstream, and all that sort of thing, and reading from their ready signal as well. Anyway, so we've got left and right, ready in and ready out. Now, I've been kind of skirting around this whole issue of PoE and Ethernet. So the first version of this that I laid out a few days ago, I stuck a WISNet chip on here, so a W5500, and an Ethernet jack with PoE, and I put a PoE module on there. So the idea was to be able to just plug this into Ethernet and have the conveyor module powered off the network, and you could send messages to it as well. But there are a couple of issues. One is pins, basically. So, well, one is size. Ethernet connectors, the thing is that this is actually a physically fairly small board. There's not a whole lot of space to put stuff on. And if we look at this, in fact, let's go to here, maybe. Come on, there we go. Okay, so this is the current state of the board. There's no routing or anything done yet. It's just, I'm just messing around with parts and sticking them in different places. So what we've got is what you can see here are the two stepper motor driver modules, which could be DRV 8871 or 8825 or something, or they could be the Allegro A4988s. So basically just plug in a module to suit whatever you're wanting to drive. These are pluggable terminal blocks that go to the stepper motors. Here is the big power switch that goes on the side. Takes up a lot of footprint on the PCB, unfortunately. But if we potentially want to be switching multiple amps through this, yeah, we can't really go for a very small power switch. So, and you might say, why would we be switching multiple amps when this is only a little lightweight conveyor with tiny NEMA 8 steppers on it? That is because my friend Plasma Steve, when he saw I was working on this, got all excited and came up with an alternative do I have this on? Camera, perspective, yep. When I'm doing layout, like adjusting things, I like to have this in orthographic view. In fact, I'll show you what that's like. Camera, orthographic. So orthographic looks really weird. It just messes with your eyes. But so if I have this at an angle like that, it looks like, see this line here? This end of the PCB, or that line there, and that line there, it looks like they are diverging. It's like a wedge-shaped PCB, but they are actually parallel. That line and that line are parallel. Because what it's doing is not applying any perspective at all. It's just drawing everything as a literal, yeah, and that really messes with your eyes. If you put it like that, it looks like a wedge-shaped PCB, but that line and that line are parallel. So, very, very strange. Anyway, the point of orthographic view is that it is more accurate in terms of being able to align things. You can see where things are relative to each other, but it messes with your brain when you're trying to get a sense of the physicality of it and how it fits together. So when I'm doing layout, I often have it in orthographic view, and then if I want to just sort of sit there and look at it and get a feel for it, I go into perspective view, which looks the way your eye would perceive it normally. So, all right, so we've got these two big connectors on here for the stepper motor outputs. These connectors here are for the time of flight sensors. We've got two power connectors, one on the left, one on the right. And that might seem a bit strange. And in fact, I could drop one of them. But I was thinking about this from a daisy chain point of view. So if I run cable into one device, and then I want to run the cable back down the frame and into the next device, I might have a few. So I'm going to have conveyor belt, then pick and place machine, then conveyor belt, then pick and place machine, then conveyor belt. You know, it's a whole series. I don't want to have to run cable all the way to each one individually. It's easier to loop it around. So, and also I don't necessarily know how people are going to be wiring this. So it might be more convenient to have power coming in on the right. We're actually looking at the back of the PCB here because it will go onto the back of the touchscreen like this. So the touchscreen would be in front of it and connected on this bottom connector. So this is the left side power switch on the left. There's a connector on the left and then connector on the right. So what I envisage is there'll be a cable coming in and plugging in on the left, and then another cable coming in and plugging in on the right. I'm showing these with edge mounted connectors at the moment, but that's not necessarily the way it will be. In fact, let's come back to here, and do a part substitution. So let's go for connectors. What do I want? MO4, and I want a vertical plug, 3.81 millimeter, and I'll stick it on one side. I don't know, whichever side that is. So then, hang on, why can't I see what's going? Oh, yeah, there we go. So that has now replaced that connector, and I'll just push that across to Fusion. I need to switch to doing this directly in Fusion instead of doing this whole synchronization thing. So Austin says, make sure you break out the shutdown on the time of flight. I've sensors fail from being on too much when not actually needing readings. Oh, interesting. Yes. So, yes, there is also another reason for breaking out the shutdown thing, which I will get to in just a moment once this is pushed. Okay, let's explain that now. All right, so these time of flight sensors, the particular ones that I've got right here, what Austin is talking about is there is an input on it. In fact, now let's go to the schematic. So what I've got is, come on, time of flight, where are they? Are they on this one? PCB sensors, here we go. So All right, it's a little bit confusing because of the way this is done, but what we've got going to the time of flight sensors is 3.3 volts and ground, kind of obvious. Then we have I2C, we've got SCL and SDA going to them. And then there is another pin here, which is going through a diode, and it is called X shut. Now, these time of flight sensors have a pin on them, which is active low. So normally it is pulled high by a resistor on, in your circuit or on the breakout. And there's one on the breakout. If you pull that pin low, it puts the sensor into a low power sleep state. So it stops, basically it's like holding it in reset almost, except that it's not reset, it's different to that. And I'll explain why this is important. These particular time of flight sensors, being I2C, have an I2C address. So when you want to talk to them, you communicate with them over I2C to that target address. But there are no address pins on the chip, like on the actual little sensor module. There is no way of reassigning the I2C address, which gives you a problem if you want more than one of them. Now you can reconfigure the I2C address in software. So what happens is the devices power up and they come up at the default address, and you might have multiple sensors all plugged in on the same bus, all on the same address, which is kind of useless. So what you do is use the X shut pin, pull it low, and what you can see on if I go back to the desktop here, you can see that I have I've got a diode, so that if this pin is high, nothing happens. If this pin is driven low, it will pull the X shut pin low on the sensor. That then puts the sensor into a low power sleep state, and it stops responding to I2C. Anyway, what this means is you can put all the sensors into sleep mode except one, and then send it a command to move it to a new IP address. No, not IP address. Move it to a new I2C address. Then you shut that one down, and you wake up the next one, and then you reconfigure that, and then you shut that one down, and you move to the next one, wake it up, and then you reconfigure that. And then you wake them all up, and they all come up with the addresses that you've configured for them. So that is why there is this X shut pin that is wired through to be controlled by the ESP32. So that what I can do is have multiple time of flight sensors, and I can shut them down arbitrarily. Now, one thing that is, the thing is that this has to be done every time the sensors power up, because they always start up. It's non-volatile. If you reconfigure them to a new I2C address, they will forget it the next time that they start. So what you have to do is initialize them by using the X shut line to put them all into that shutdown state, and then reconfigure them and then wake them up. But you've got to do that every time you reboot. But what this also gives us is the ability to power down the sensors using the X shut line if we didn't want to be using them. So Austin, that is a very, very good point, because the thing is that we actually only care about those sensors if we are in the process of, say, loading something onto the conveyor belt or offloading it, and we want to detect the fact that it has passed the exit sensor. So what the logic can do is shut down all of the proximity sensors unless the conveyor belt is in motion. And I think that's probably a good way of extending the life of those little time of flight sensors. Right. Yes, so Austin, thank you for bringing that point up. That is very important, both from a lifetime point of view of the sensors, and also for just being able to reconfigure them. Now, let's talk a little bit about this IDC6 connector, because that connector is one of the reasons that we're using up so much, okay, refresh, that we're using up so much real estate here at the moment. Now, I've been thinking a lot about the form factor of this, and I don't want to make it bigger than the screen if I can help it. Like, ideally what I want is for this carrier board to go, yes, refresh, is to go onto the back of the display, and then there is going to be like a triangular shaped 3D printed enclosure, and I want the display basically to be almost the size of the enclosure. So I could increase the size of this PCB to make everything fit, but my goal is to get everything squashed into that space, just to make it cool. Now, where are we? Oh yeah, that's right. So what I just did was I replaced the footprint. So for these pluggable terminal blocks, they can either come out the ends of the case, or I can have it come out the back of the case just by using vertical versus horizontal mount pluggable terminals. So that's also something that I'm going to be messing around with. And the nice thing is that there is no commitment to that either way, because the same footprint works both ways, and the only difference is the enclosure and how everything plugs in. So I think it might actually be quite neat to have the connectors come out the back. And that's going to depend on clearance. So from the front, all you would see is a really neat enclosure with the touchscreen and a power switch on the side, and that's it. Everything else would be concealed behind it. Now, oh yeah, so what have we got here? CAN bus on here, and that's the termination selection for the CAN bus. I thought about putting this on an external termination resistor that is on a connector, and you plug it into the thing. So I should explain. These four-way headers are for power and CAN bus. So it would typically be like plus 12 volts or 24 volts and ground, and then CAN high and CAN low. And if you wanted to, you could just plug in a two-way terminal block and just supply power to it. You don't need to use CAN bus if you don't want to. So CAN, all right. What I was thinking is these have Wi-Fi. So right now, that prototype that I've been showing you, I can publish G-code commands to MQTT, and it responds. Like, I can tell it to home, I can tell it to go to a position, etc. But that's using Wi-Fi, and I do not want to rely on Wi-Fi in the production environment. I want wired communications. The first thing I thought of, as Austin suggested, was PoE, and like Ethernet with PoE, which solves the power problem as well. One cable, you plug it in, and you're good to go. Austin said, isn't the diode backwards if you want to pull them low? Maybe you might have picked up on a mistake I made. I'm going to look at that in just a second. What I can do, and the thing is that if this is going into kind of a semi-industrial environment, CAN bus is more the way to go anyway. In places like production lines, things like RS485 and CAN bus are like the de facto standards. That's how stuff is done, apart from just switch contacts, which seems to be what everybody falls back on. But I could do something like implement CAN open on here, or yeah, whatever. I can use CAN bus. So the idea is that single cable that plugs in here provides it power and communication, and it can loop around from one device to the next. They can each have their own identities on the CAN bus, and I can communicate with them. Then at the other end, I could use an Ethernet to CAN bus bridge, and that way one network connection, and it would then connect to all of the devices on the bus all the way down the production line. Right, so I figured that CAN bus would give me the most flexibility. I would like to have Ethernet on here, but I could not have both Ethernet and CAN bus, and CAN bus is smaller physically on the thing. Like if I put it's a little bit hard to get a perspective on it. In fact, let's do it. I'm going to stick a, unfortunately I don't have that version anymore. I had an earlier version of this which had the Ethernet and everything on it. I didn't have a lot of the other stuff, but it just took up most of the board. What am I doing? Adding a part, that's right. So let's stick a, what have I got? Hand run, that'll do. Let's stick a, oh, let's stick a hand run Ethernet connector on here with the magnetics and board. Where is it going to go? Where are we going to put it? Let's just move it. Let's stick it over here on top of the other parts, which is going to, like from a physical point of view, that makes no sense whatsoever, but at least we'll get a sense of the scale of it all. So while that is happening, let's, oh, why is that? It should have come up with a, oh, there we go. This is taking a long time. Oh, yeah, Austin, I was just about to go and check out the diodes based on your feedback. So never mind, I was thinking of the connector backwards, the diodes are right. Okay, cool. Thanks, Austin. It's always good to have someone check though, because, yeah, it's not unknown for me to make a mistake. I just keep making mistakes until I get it right. That's my general approach. And eventually, if you make enough mistakes, the only thing left is the right way to do it. So, I was also thinking about having a vertical Ethernet connector on the back so that the cable could come in directly from the back of the enclosure. That would be kind of cool. Loading. All right, so it's like, this is like a teleporter accident. Two people got teleported into the same location and they're overlapping. So we've got an RJ45 or 8P8C socket there for Ethernet, and we've got the pluggable terminal blocks. So yeah, you can see that the Ethernet connector is huge, and that is just the connector. Then there would be a big area on the back here which is taken up by the WISNet Ethernet chip and all of the other things that have to go with it. So basically you end up with a quarter of this board gets taken up just with the Ethernet. And yeah, so as Austin was saying before, it would be nice to have an Ethernet and PoE board for this touchscreen. Oh, Gerald, welcome back. Because what was I thinking of? I don't know. Yeah, it would be really, really handy to be able to mount this in an enclosure and have Ethernet to it and a touchscreen interface. Fantastic for home automation projects. So now that I've got into using this screen for this particular project, I'm really enthusiastic about it. And I think one of the next things I'm going to do is design an add-on board that is just Ethernet. It doesn't even need to be anything else. It can be an add-on board which has got an Ethernet socket, PoE regulator, and that's it. Like, for most use cases, I could probably put a bit of prototyping area on there as well, but just adding Ethernet and PoE to this touchscreen module, that would be like a killer. It would be such a useful little device. So yeah, I really like the idea of doing that. Now, other things. Okay, these modules. I said earlier that I was going to explain why I'm using these modules, these stepper driver modules, instead of integrating stepper drivers directly onto the PCB. The first reason, and by far the most important reason, is that I'm lazy. It means that I can just put down the footprints for these and I can plug in these modules. And these stepper driver modules, they're only a few dollars each. They are shockingly cheap. And they come in a whole lot of different varieties. So you can get one that has the particular characteristics that you want, depending on what steppers you're going to be driving. In my case, I'm going to be driving tiny little NEMA 8 steppers that take very little power and yeah, aren't really going to stress this system at all. But when I was working on this, and you can see, well, it's called Conveyor Controller. It was called PCB Conveyor Controller until I showed this to my friend Steve, and he got really excited about it. because he has a use case that I never even thought of. So one of the he does a lot of messing around with things like Linux CNC and controlling CNC machines and laser cutters. He's built a big table router. He's built a plasma cutter, hence the name Plasma Steve, and various other things. So he often finds himself in a situation where he has to do something like read a limit sensor and drive a stepper motor and control it in some convenient way. Now there are lots and lots of boards around that'll do that. There are like 3D printer control boards, things like smoothie boards and all of those sorts of things. There are many boards that are designed for a 3-axis system, say 3-axis plus extruder and heated bed, so like a power output control and some temperature sensors and various other things, and like an input for a filament sensor. As a package for running a 3D printer, that's fantastic, but it is massive overkill if you basically just want to drive a single axis with a limit sensor and that's it. And so yeah, when he saw this and the idea of it being in a very small package, so we're talking about like deck of cards size package where the front, almost the entire front, is a touch screen, and driving a stepper motor and being able to read from a limit switch. He saw this and thought, I could use that in so many things, like things that he's building add-ons to equipment, where he doesn't want a full control system like a equivalent of a 3-axis plus extruder, etc. control system. He just wants to be able to control an axis, home it, and send it to different positions on command. And the first use case, the thing that he's wanting to do with it immediately, is control a powered backstop on a metal bending machine. So the way metal is bent, let's have a quick look. Yeah, there are different bend brakes. What is it? Brake. There's a press brake, a sheet metal bending brake. Yeah, metal brake. Let's bend brake. All right, here we go. So press brake. Let's try that. See what we get for it. Okay. Here is an example. Oh, there's an old one. Why is it called a press brake? I have no idea. Okay, let's look at some pictures. Here's an interesting picture. So what you can see here is this machine. In fact, this is a really good example of exactly what I am about to explain. What you can see is this piece of metal in here is the workpiece. This is what's going to be bent. And then there is a shape on the bottom and a shape on the top. And this is going to be pushed down. So the bottom piece, this shape here, is fixed in position. This bit on the top is about to be pushed down with a huge amount of force to bend this piece of metal into a specific shape. Now, usually when you do that, you want that bend to occur at a very precise location. It needs to be the same every time, so that when you're taking a piece of metal and you're bending it into a shape, you don't have that bend occurring at a different location. And the way that is done is by setting the depth using this piece at the back. So this block of metal here, which stops the workpiece from going any further back. You put it in, you butt it against it, and then you know that it is at the set position. So the depth guide here, this backstop, is adjustable. And if you are doing a production run of a whole bunch of different pieces, and the thing is you have to take into account the characteristics of the metal that you're bending, because as you start to bend it, it will pull away from the back typically, and it'll move in a certain direction. So the way that the fold ends up is not necessarily exactly based on where it starts. Well, that was the wrong way of saying it. The final position of the fold will not necessarily be at the position where you begin applying the pressure. So what has to be done is you do a bit of a tuning process. You'll put it in, fold it at that point, measure it, see if it came out in the right position, adjust the position of the backstop, and then do another one and measure it, and you can iterate a couple of times until you get it so that the bend is coming out in exactly the place that you want it. And that's what the position of this backstop does. And so, but usually what you want to do is have the backstop move out of the way, because there might be, it might bind up on the edge of the metal. So what will often happen in these machines is you will load the workpiece, it will hit against the backstop, the top will come down and touch the workpiece, and but not actually really do the bend yet. It's just sort of pushing against it. As that happens, the backstop will pull back out of the way so that it's clear, and then it completes the bend, releases, you take the workpiece out, and then the backstop moves back into position, and then you're ready for the next one. You slap in the next piece of metal, and it's in the exact same position as the previous piece of metal. Now this is the critical bit. Moving this backstop out of the way and then returning it again in a precise, repeatable way quickly. That is what Steve wants to be able to do. And that's where that's where this project comes in. So what he's in the process of doing is building a powered backstop for a press brake. And he wanted a way to be able to control the position of that. So what he wants is three things. He wants a stepper motor control, which can then go to something like a ball screw. So there'll be a ball screw that will move that back piece into the correct location. To keep it simple, it could be closed loop, but to keep it simple, what we'll probably do is just have a limit sensor, like a homing sensor. So we need a homing switch input, and we need a brake, because what he will do is, in order to make this really lock into place, there will be a brake. And you can think of that as being like a disc brake on a car, or disc brakes on a push bike. There's a metal disc with a clamp that closes on it, and it's spring loaded so that when the spring is pushing against it, it will clamp on the disc and it can't turn. So the idea is that the drive shaft that moves this will have a brake on it, and when you apply voltage to a solenoid, it will release the brake, and then you can move it. But if you remove the voltage, the springs clamp the brake pads onto the disc, and it locks this backstop in place. So he wants output to control the solenoid for the brake as well. So that is where, let me get back to this. Okay, so that is where the flexibility of having these modules comes in. Because what we've got here, this is for my application, a conveyor controller. I've got an X stepper, which is actually going to drive two stepper motors, and they'll be going in opposite directions because they're facing each other, and the Y stepper. But what we can do is use the Y stepper output to control the stepper on the ball screw for the brake on the back of the bend press, or the press brake, whatever you want to call it. And then the other output, we can change this to drive a solenoid, essentially like a DC motor, by replacing this module. So when you're driving a stepper, typically these will have a little stepper motor driver chip on them under here, under that big fat heatsink. And so that's driving two coils that are 90 degrees relative to each other in the stepper motor. And with some stepper modules, you can drive them kind of drive DC motors with them. But what I was thinking of doing is, if we come back to here, I was just messing around. DC stick, this'll do. This one. This is basically just a big N MOSFET on the same footprint as the the stepper motor driver, but all it does is provide power, like that you can modulate if you want to. So these are the connectors for that little stepper motor footprint. We've got the voltage coming in for the motor, we've got a ground connection, and then normally you have 4 wire outputs coming here. There would be 2B, 2A, 1A, 1B are the 4 outputs here. So the 2s are just missing, they're not connected to anything. And then the 1A and 1B connections go out. So we've got positive, you can't even do direction control with this. It's just controlling an output with a big fat MOSFET. So we've got the input voltage coming through here going out to the motor or the solenoid, and then the negative connection comes back into here through this MOSFET and gets switched to ground using the step input. So it is super simple. It is just controlling some external load with a high current MOSFET. And let's come back to here. And what am I looking for? Superhouse modules. Somewhere in here. What did I call it? I can't even remember what I called it now. DC? There it is, DC stick. Okay, so this is the this is that little module. It is just a MOSFET. There's a reverse protection diode on there, and a couple of resistors, and that's it. So what you can do is drop this module onto this board in place of a stepper controller, and now instead of having a stepper connected, you would use the 1A and 1B pins, and you could fire a high current solenoid, or it could be a DC motor, or it could be a relay that then, or it could be a pneumatic actuator, for example. So typically, like a lot of the time these things use compressed air, and then we want to be able to control an air solenoid to fire something that is air powered. So what that would do is allow us to use this same carrier board and control a stepper motor plus a high power solenoid off the same board. And all we do in the firmware is use the step pin right there to control the output on the load. Now, it may well be that people have already made modules that do that, and I might be reinventing the wheel. But I was sitting in front of the TV a couple of nights ago, and I just quickly laid out this, and I did another version as well, which is, come on, where are we? HB stick, there it is. This is just an H-bridge version of the same thing, so that we've got the ability to do direction control. So that's a little H-bridge for controlling a DC motor using the 1A and 1B outputs, same as before, with step and direction pins being used to control the in1 and in2 pins on the H-bridge. So anyway, just playing around, doing things for fun. Yeah, so the point is, this could be a like a focused, I'm struggling for the words, kind of an optimized little control module for when you've got a situation that is much simpler than a 3D printer. You just want to control a stepper motor and a solenoid or something from a little touchscreen and have CAN bus interface and that sort of thing. So anyway, this could end up being a useful little device. So what I've got here is, these are the read relays for the ready out connectors, and then I've got Opto-isolators here for, which one is it, ready out or ready in? I can't remember. Anyway, Opto-isolators and relays, those are for the connections to the adjacent machines. This is the MCP23017 I/O expander, which I may replace with a 23008 just to make it physically smaller, because I don't need all of those inputs. Just as placeholders, I've put in these connectors. So these are the connectors for the ready in and ready out on the left end of the machine. And this stuff is related to the the ready in, ready out connectors as well. So these are the transistors to drive the read relays, and then just, you know, bias resistors and other miscellaneous stuff. Yeah, so CAN bus termination, I've already mentioned that. Is anyone still here? Doji said, well, would that have enough power to turn a ball screw with a load? It depends on the size of it. So the thing is that because this has the capability of controlling a brake, the ball screw does not need to withstand a huge amount of load. It doesn't need to take direct thrust onto the end stop, because what we can do is move the end stop with the brake release and then apply the brake, and then the end stop is locked in position. So we're not relying on the ball screw to provide the anchoring of the position, which means that it doesn't need to be super high power. It just needs to be able to move the end stop. Once it's moved its position, it's locked and the load is taken off the stepper. Right. Chip said there isn't enough room for a squirrel on the board. Yeah. I'm going to fit one on somewhere, even if it has to go on the other side, because there's nothing on the other side of the board. Let's see, I think it's still in the... come on. Oh yeah, it is. It's still in the board layout. You can't actually see it in the 3D render because it's off the edge of the PCB. Oh, hang on, you can't see that because my face is in the way. Sorry, Steve. So I've got the silk screen just hanging around here ready to go on the board. But as you can see, there is no routing done at all. I've just been messing around with putting things physically in place and trying to make it all fit. Now, a question for all of you. These opto-isolators, what have I got on the board here? LTV816. So opto-isolators tend to be physically annoyingly big. The other way around, annoyingly physically big. These things are huge. Like, look at them compared to the 16-port I/O expander. They're like just as big as the 16-port I/O expander. It's silly. So one of my questions for all of you is, have you seen smaller opto-isolators? It would be nice to have, it'd be nice to have much smaller opto-isolators, because they just take up so much real estate on the PCB. This is the voltage regulator module. As a starting point, I just slapped down an off-the-shelf regulator module. It's 5 volts, 3 amp rated. I've used these in a few projects, and they seem to be generally reliable despite being super cheap. So, I don't know, that'll do. The only thing this is powering is the ESP32 anyway, like in the screen and stuff. So the loads aren't being powered through this, it's just the logic. Just use the PCB817s in a PC817s in a project. PC817, yeah, this is an LTV816. I think the LTV might be like manufacturer number or something. My guess is that the PC817s are basically the same thing. PC817, yeah. All these optocouplers seem to be pretty much the same. What is a PC817? It's an optocoupler. So, yeah, they all tend to be either through hole or surface mount in this sort of wide format package. And I've had a bit of a browse through DigiKey and looked for something smaller, and I can't come across one. So I just thought I'd ask if any of you have come across something. If you go smaller horizontally opto, wouldn't you end up with more vertical dimension? Yeah, but vertical dimension actually is not a problem for this. Because there are already high things on the board. Dentistry said, oh, so you haven't been on for so long, started a new job. Congratulations on the new job. I hope that's going really well. but I've hidden 3D printed squirrels around where I work. Secret Steves, like Secret Santas. Now if I go back to the 3D view, ignore the ridiculous RJ45 connector for now, but there are already physically high things on here. There is a switch, there are these modules which may or may not have the thing on the back, the heatsink, but there will be plugs into these sockets, there will be plugs into these sockets. So physically this is already quite thick. Vertical space is not a problem. Horizontal space is my problem. So yeah, my goal is to squash these parts that are off the board at the moment. I need to squash them onto the board somewhere. So the obvious thing is that these read relays just move directly down from where they are now. They can just go in the top part of the board here. Then these can go in here somewhere. But then where do the connectors go? I need to get 2 connectors on each end for ready in and ready out. So yeah, it's going to be a bit of a squash to finish it. The thing is that there are very few small parts on this board. It's mostly just big connectors and other, like the switch, relays, which are huge. It's all just stuff that gets in the way. It's yeah, when this design is done, it's going to be a relatively simple board in terms of the surface mount parts. The surface mount parts are going to be just a few, squashed in around all of these massive connectors. And yeah, maybe I could go for smaller connectors, but then it's less convenient. Yeah, my goal is to make it all fit. I shall see. Ooh, Sion says you can save stacks of room by removing that switch and putting a small slide switch that drives a load switch OC. They are like 30 cents and can switch 5 amps or more and a SOT23. Really, 5 amps in a SOT23 package? Nice. That could certainly be an option. And with the load switch you get overcurrent protection. That is a cool idea. Thanks, Sion. Sorry, I do need the drink. My throat is getting froggy. So, yeah, just back here. Let's see. Let's get rid of this and push that again. Push, push, push. So, yeah, okay. So that would allow me to use a really, really small switch. I like that idea. Thanks, Sion. See, this is why it is good to design things kind of in public. Because I get good feedback. So Chip said, can I delete the Optos? What would happen? So I could do it without the Optos, but my preference is to leave them in. Not really necessarily, oh, it's finished. Not really necessarily even for my use case. I'm starting to think about other use cases like, well, actually that doesn't even apply. Sorry, I'm thinking out loud here. So what I was thinking of was use cases where this is in a much more industrial environment. Like, imagine Steve was using this to set up a conveyor belt to run stuff into his plasma cutter. And so this is going to be having signals coming into it on wires that are meters and meters long, running past a plasma cutter, which is generating massive electrical noise and doing really, really bad things. We want the controller to be isolated from it and not being affected by it. So having opto isolators on that would help. But it's not, yeah, they're not strictly necessary. It's just kind of good to do that. Let's update that. So if I had to, like for my use case, I could get away without them. And another way to do this would be to, instead of use opto-isolators, just use transistors. Like I could just put a little, you know, N MOSFET or something in there and feed that through from the external thing. So instead of having this big package here, I could have a little, you know, SOT23 package. It just wouldn't give the same really high level of isolation as an opto-isolator. Oh, Peter, yes, 10 minutes to lunch. Is it? Yes, it is 10 minutes to lunch. Yeah. So, okay, so Chip says, the question wasn't rhetorical, I wanted to hear your reasoning. Yes, so there is some reasoning behind it, as much as there ever is with my designs. No. I probably should have muted my phone before I began the live stream. I need a checklist of things to do. What am I doing? That's right. Let's look at these optos. No, not that. I was wanting that. Where are the optos? Here. Ready in, ready out. Okay. So what this is doing is allowing everything on the external side. Now the thing is that the power supply line in this case is still connected through. So here we've got the 5-volt rail, which is being used to feed into the ESP32. Now, admittedly, there is another voltage regulator involved. So the 5 volts does not go straight to the ESP32. The 5 volts goes to a 3.3 volt regulator, which goes to the ESP32. But this is potentially a danger, because what we are doing here is taking the 5 volt rail and exposing it through this resistor out on this wire that could potentially run meters and meters around a factory, past big electric motors and arcing, you know, like plasma cutters and all of that sort of horrible stuff, and then coming back around and into this side of the optocoupler. So this here is potentially a danger, because if there is noise being induced in on this wire, it could feed back through this 120 ohm resistor and affect the 5 volt rail, which is kind of not ideal. So if we were making this really ruggedized, what we would do is have a dedicated voltage regulator that is feeding the rail for these inputs. But that is another step again beyond. Jordan says, run it from your 24 volt rail. Yeah, that'd be a good way of getting an extra bit of isolation. So we've got, where am I looking? Oh, wrong sheet. All right, so we've got power coming in from CAN bus. So we've got V-raw is what I've called it. So power comes in on the external connector, and then it goes through this diode, just for a bit of reverse polarity protection, to a net called V-in. V-in then comes to the power switch, and then it goes out to V-switched. So this is what Sion is suggesting I replace with a little low power switch, and then like a silicon power switch. So I'm going to check that out. Actually, while I'm back on that subject, okay, so I'm just looking back at the chat. Sion said, I lied, the SOT23 I'm using are only 2.4 amp limiting, might need a slightly bigger package, still way smaller than the switch. Yeah, so I am curious to know what you are actually using. So, Johnny says, feeding that with 5 volt makes no sense to me. Okay, there was reasoning behind that as well. and that is that I don't know what the input voltage is going to be. And at least this way it's consistent, and I can set the current limiting resistor on the optocoupler to be optimized for whatever the voltage rail is here. So the input that comes in here on VRAW, for me personally, I think I'm going to send 12 volts in here. But for many other things, it might be 24 volts. Yeah, maybe that'll be okay. There's probably enough latitude that if I just set the resistor on here to suit a 24 volt rail, then it should still work at 12 volts as well. The LED should illuminate enough that, that it reaches the threshold and turns on. So yeah, I think you might be right, Johnny, that maybe I should feed this, and someone else suggested it as well. Jordan suggested run it from your 24 volt rail. Yeah. So maybe what I should do is this. Take that off there, and let's, it's going to have the wrong net name for now, but let's just, oh no, it's not, because I decoupled it from that, that supply symbol. So what am I going to call it? I'm going to take it to V-switched. Alrighty, make that V-switched and join nets. So now this will be getting, let's bring it along a little bit. So now this will be getting 12 volts or 24 volts. Whatever is coming in would run through this, and I'm going to have to calculate the value, but let's make this, I don't know, what would it be? 560 ohms, give or take? I don't know. I will figure that out. But anyway, the so what we would do is be taking the switched input voltage and then feeding that through. So effectively it'll be getting like 24 volts coming back out here and coming in through the Opto-isolator. Yeah, overall I think that is better. So yes. Thanks, Jordan and Johnny. I think that is probably an improvement. It really helps isolate the 5 volt rail from any nastiness that's happening external. Add a diode before the resistor to prevent backfeeding to the 5 volts. Yeah, I see what you're saying. So put a diode in here. That would have a bit of extra voltage drop. Yeah, I don't know. I think this is a better solution. Let's just take the supply for the Opto-isolator off the input voltage, and that should be fine. Oh, Chip says 3 minutes. Hang on. Dodgy, did you just put a loading symbol in the chat? Okay, so Sion said I'm using this. Oh, there we go. Okay. Sion has just provided a link to the silicon switch. Power distribution switches. Yeah, cool. Thank you, Sion. That's a really good starting point. So for my purposes, 2.4 amps would actually be enough, because all I'm driving are from some fairly small stepper motors. But maybe something, yeah, I'll find something equivalent to that that is a higher rating. Okay. I started this live stream with the intention of just using it as a bit of a test to see if running OBS on my iMac as an external device and capturing would work. And so far, that seems to be a success. It's actually kind of working. But I didn't expect to do the entire 2-hour stream. I thought I'd probably talk for half an hour. I'm only limiting to 1.2 amp. Can you... Sion says, datasheet says up to 3.6 amp, but not sure I trust it. Johnny asked, can you put those in parallel? Putting putting things like power switches and MOSFETs in parallel to increase their current capacity is actually kind of dangerous. There are some hidden traps because of the way they work. Switching, one of the things that I've had problems with in the past is that anytime you want to switch power and you want to increase your current capacity by putting things in parallel, you can have issues. It can be, for example, say you're putting two relays in parallel to switch a load because you want to run through both of the contacts. If one of those relays fires a fraction of a second before the other, like it's just a little bit quicker, the contacts close. Those contacts are then carrying the full current briefly before the other contacts close. And so you can get arcing and degradation of those contacts over time. Now I'm talking about an electromechanical system there, but the general principle is if you're wanting to switch power, it's best not to parallelize things to get the current rating you need. It's best to use a thing that is rated to the current you need. Now the same applies with non-electromechanical systems, with things like if you have two MOSFETs and you put them in parallel because you want to switch a high current load, there can be some issues where you have different characteristics in them. One switches on before the other, and even though things like MOSFETs are very, very fast compared to something like a relay, which is mechanical, it's got to physically move, you can still have similar things go wrong. And you can end up with a bit of a cascade failure effect. Like I've seen this in UPSs, because UPSs are the classic situation where you're having to switch high power. And I saw a situation a few years ago where there was a cascade failure effect in a UPS because it had multiple MOSFETs that were switching a high power load, and you get one fail, and then all of a sudden you get extra load on the others, and then they fail, and it's like bang, 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 you just blow everything. So, right. Yes. Okay, so, all very interesting. So Jordan just said something interesting, which is, I still say I should use the ATEM to handle the final encode. Yeah, I was thinking about that. But I did not quite get that set up before this test. So it's still possible. What I could do is, what I would need is an extra capture, because in order to do that, the way I was doing that previously was in OBS. So I had an external monitor connected, and then on OBS I enabled full screen preview, and then what I did was use the ATEM to capture that external monitor, and then it was doing the final encode off that capture from the full screen preview. So that has actually been working pretty well for me for the last few months. That's my live streams for months now. That's exactly what I've been doing. But what I need to do, the thing is that I'm at the moment running OBS on my iMac, which is sitting off to my left. It doesn't have an external monitor, and it only has Thunderbolt external outputs. It doesn't have like an HDMI output, so I can't just plug HDMI into it and then into the ATEM and capture it. I would need to set up like a Thunderbolt to HDMI adapter and then capture that. Anyway, it can be done. I just didn't get it done this morning before the live stream. But Jordan, yeah, you're right. I think what I need to do is keep the ATEM in the system and have it do the streaming, do the encoding and the streaming. Yes. Now, I am going to go in a second. In fact, I think I should go now. Scott, very good question, Scott. Scott said, feeling better than 3 out of 10 now. Yes, I am. So often I start these live streams feeling like, oh, I'm not up to this. It takes so much energy and focus to do a live stream, and even if I'm just going to be winging it, there's still a bit of preparation. There's getting all the gear set up. It feels like a hurdle to get past, to get started. But then once I get started, and I start chatting to you all, I always finish live streams feeling better than when I began. So, thank you. Yes. And I always learn stuff because so many clever people hanging out here, which is really, really cool. Lots of ideas and feedback and suggestions. Alright. Now I am going to go. Peter, please like the stream for the stats. Yes, thank you. I'm going to go and have some lunch because I'm hungry. Because I missed morning tea. No, I missed second breakfast, I missed morning tea, and I missed 11's. So, yeah, I haven't had any meals between breakfast and lunch, which is a tragedy. A terrible, terrible thing. What am I doing? Yes. I'm ending this live stream. Somehow. How do I end this live stream? Yes. Have a great Sunday afternoon or Sunday or whatever it is. And I've got to find the end button. Here we go. Okay, thanks. See ya. Is it working?